Hello. In this class, in this video lesson, today we'll talk about the last part of divisibility. It's about division algorithm. Uh, let's start with this definition. Let's say if A is not divisible by D, then there will be a remainder after division, right? Because we know that if a number A, let's say integer, is divisible by D, we know that actually can just write it as the product of two integers. Like for example, let's say 6, right, is equal to 2 times 3. And 6 is the product of 2 and 3, and 2 or 3, they are divisors of 6. But for example, here, if we divide 7 by 2, for example, we cannot write it only the product of two integers. Still, we have left over that is smaller than the remainder. So here we have 1. So usually, actually, every integer can be written in general in this form. That is, A is divided by, if you divide A by D, the quotient is Q and the remainder is R. Because here in long division, if you divide A by D, right, and we get some quotient, let's say Q, and also here we may have some remainder, let's say R. So how we actually express this as an equation. So here we are dividing A, we call this dividend, and dividing A by D, we call this divisor, and the result is Q, that's quotient, and remainders R. So that means that if you multiply D by Q, and after the some smaller part, that's the R remainder, then we get A. So this equation is very important equation in not number theory, let's say division algorithm. Because usually every integer can be written in this form, that if you divide by some integer, if you divide any integer by another integer, and we have some quotient, and also we may have some remainder. Okay, for some examples, for example, we can just write here like 25. Let's say A is equal to 25. You change the marker color here. Or let's say 25. If A is equal to 25, for example, let's say if you divide this by -6, let's say D is equal to -6, then this 25 will be equal to, if you are dividing this by -6, so it is -4, right? The quotient is -4, and our remainder is 1. How about if A is equal to -25 and D is equal to 6, for example? So then -25 is equal to 6 times, here we have -5, and plus -30, here we have 5. And here, when we're just writing this definition, actually, here we have one condition, that the remainder is always less than divisor. Otherwise, as you see here, if remainder is greater than or equal to D, still I can keep dividing this, right? And when should we stop this division? If R is equal to D. And that's why here, if I divide a number by 6, right, this remainder should be less than 6. And another example, for example, how about if A equals -25 and D is equal to, let's say, -6, okay? At the time here, we have -5 is equal to -6, and here we have times 5, and here we have plus 5. All right. All right, that is called the division algorithm, dividing a number or integer by another integer. Okay, and even in general, actually, if you just divide by any polynomial by another polynomial, always we have this form, that dividend equals divisor times quotient, and also here we have a remainder. And actually, if remainder is equal to 0, then we say that A is divisible by D, or D divides A. So let's start with this theorem. For any integers A and D, and of course here D should be different from 0, otherwise we cannot divide any integer by 0. We don't have 0 division operation in real number system. Actually, in general, in math, we don't actually divide any number by 0. It's not defined. So there exists one and only one. And we are just emphasizing that's only unique, right? It's only one pair of integers Q and R such that they satisfy the first equation. and the second one, this one. And we are saying that if you just pick any two integers, was our first equation. If you just divide a by d, and here we have quotient, and here we have r. And also here, what is r? R is between, what is it? R is between, it may be 0 or greater than 0, because with a 0, we just say that d divides a, and it should be less than absolute value of d. Okay, so uh, here we are saying that there exists only one and only one pair of integers q and r, such that they satisfy this, the first equation. Actually, this one is the first one, and also actually here it satisfies the second one. So now actually when we talk about this kind of theorems, actually we need to prove two things. Number one is it exists. Number two is it's only one. So in math we call this existence and uniqueness. Okay, but usually this existence is quite about this level. Maybe it's not in the scope of this course right now. Okay, in the future we may discuss this, but right now we are just going to uh, prove the second part, the uniqueness. It's only one. And but only one, what we are saying here, what we are trying to say here, we are claiming that if you give me any integer a, all right, and if you give me any integer d, all right, there's only in one way I can describe this a as d times q plus r. All right, there's not second way. If the second way is exactly just copy of the first way, which means that it is unique. Okay, usually in this kind of situation, math, actually we just think the the uh, the opposites, let's say we have some opposites notion about this proof. For example, I just claim that, suppose that actually our claim is wrong and there is more than one. Okay, and suppose that we have two different representation of this a and d in this way. That means that here, let's say a is equal to 1 if I divide d, and it says that there's only one way. So let's say the first one is q1 and plus r1. And here, of course, this R1 is between, what is it? 0 and the absolute value of D. And the absolute value of D is not inclusive. And also we are saying that, let's say we have another form. Let's say A also can be described a bit different form. That is A is equal to D times QT plus R2. And also here, 0 is less than or equal to R2. It is less than D. Okay. So now from here, if we just subtract this, see here, R1 is less than, strictly less than absolute value of D, right? And also R2, it is less than or equal to or just less than absolute value of D, right? Now from here, also actually I can see that here, this R1 minus R2, and also it is less than absolute value of d, right? Because both are part of the integers, and these integers are less than d. And also, if you subtract, they get smaller. Even they may get in the negative number, but actually, after all, they get smaller, and that there will be less than the difference will be less than this d, absolute value of d. Okay, so what happens if I just subtract side by side? Okay, let me just subtract the second equation from the first equation. On the left hand side, here we have a minus a, that's equal to 0. On the right hand side, d is a common factor. I can just keep this outside the parentheses. And here we have q1 minus q2. And plus, here we have r1 minus r2, right? And if you look at this equation, what do we see here? Let me just write like this. I can just write it as d, right? Or let me just write r1 minus r2 on the left hand side. R1 minus r2 is equal to d times, I will just interchange these q's, okay, just to avoid that a negative sign, but actually it doesn't change anything. Let me just write here q2 minus q1, right? So R1, R2, D, Q1, Q2, they are all integers. That means on the right-hand side, we have the product of two integers. And from this relationship, what we see here, that means that this D is dividing, right, the R1 minus R2, right? So D is dividing R1 minus R2, which means that this R1 minus R2, right, is greater than or equal to D. right? But here we just say that here there's a contradiction here, R1 minus R2. We are saying that it is less than absolute value of D. Now here we have just the opposite of this, what is it, claim. Here we have R minus R2 is greater or equal to D. We don't have such number that is less than 5 and greater than or equal to 5. What number do we have? We don't have such number, right? So there's a contradiction. So that means that this cannot be greater than or equal to D, right? So which means that then the only way is here is this R1 minus R2, it should be equal to 0. So which means that R1 is equal to R2. If R1 is equal to R2, and also this implies that Q1 is equal to Q2. So what do we understand from here? That means that there's only one way to describe any integer, okay? If any two integers, let's say A and D, in this way, where A is equal to D times Q plus R. We cannot show this in the second way. That is really important theorem. So let's just see one example. If the remainders of dividing integers n is greater than 0, that is non-negative integer, by 7 and 9 are equal to 4 and 6 respectively. Find the minimum value of n. Okay, so this says that if the remainders of dividing integers, integers by 7 and 9 are, it's actually should be integer, dividing integer n, which is non-negative, right, by 7 and 9 are equal to 4 and 6 respectively. So that means that if I divide n by 7 and we have some quotient, let's say this q1, the remainder is 4. And also if I divide this integer n by 9, that's 9, and we have quotient is different from the first one because we are dividing by different numbers. And here the remainder is 6. The question is find the minimum value of n. Right? From here, if you notice here, if I just add 3 to the first and the second equation, I mean to both sides of the equation, you will see that n plus 3 is divisible by 7. N plus 3 is divisible by 9, right? And by just adding this 3, see here, n plus 3, on the right-hand side, 4 plus 3 is 7, so I can just write this 7 times q1 plus 1. And the second one becomes n plus 3. N plus 3 is equal to 9 times q2 plus 1, right? And also we know that n, q1, q2, they are all integers, which means that here n plus 3 is divisible by 7. At the same time, n plus 3 is divisible by 9. And from here, as you can see, 7 and 9, what is the 7 and 9? The 7 and 9, they are relatively prime numbers, relatively prime numbers, right? So, and also in the previous classes, we proved that if two numbers are relatively prime and they are dividing the same number, that means that this n plus 3 must be divisible by the product of these numbers, 7 and 9, right? Because they don't have any common factor except for 1. So since we are looking for the minimum value of n, right? And so when actually n has minimum value, if n plus 3 is the minimum. So now from here, what is n plus 3 then? N plus 3 is the least common multiple of 7 and 9. And the least common multiple of 7 and 9, that's equal to 63. So now from here, what is n? N equals 63 minus 3, that's equal to 6. So that the minimum number, when you divide by 7 and 9, they leave the remainders of 4 and 6 respectively is 60. Another example, actually it should be example 2. All right. Another example, the remainders of dividing 352, 306, and 191 by D, where D is greater than or equal to 2, are equal. Find the value of D. And since actually we are talking about two different D integers, right? 352 and D, 306 and D, 191 and D, there's only unique way, right? Like writing this in the form of equation 1. What is this? That's 352 If you divide this by D, we have some quotient. Let's say this Q1, the remainder is R. And it says that again, if you just divide this 306 also by D, we have another quotient, and the remainder is again R. And if you divide 191 by D, right, we have maybe different quotient, the remainders are. Because in the question is saying that the remainders of dividing these three numbers by some D, some integer D, they are equal. That's why actually I'm just using the same variable to denote the variables, they are equal. And also, we have already proved that in our previous classes, actually, if a number is divisible by D and another number is divisible by D, that means that those numbers difference is also divisible by D, right? If M is divisible by D and N is divisible by D, that means that also M minus N should be or must be divisible by D. Now from here, why is this so? Because here, if you just subtract, here we have three equations. Subtract the second equation from the first one. It's 352 minus 306. That's equal to 46. On the right-hand side, R minus R is equal to 0. D times Q1 minus D times Q2. D is a common factor, so I can just write it as D times Q1 minus Q2. And how about the second and third? 306 minus 191, it is 915. So the difference is 115. On the right hand side, D is a common factor. R minus R is equal to 0. So here we have Q2 minus Q3. And notice that all of these variables, they represent integers, right? And what is 46? 46 is 2 times 23. And how about 115? That is 5 times 23. So here we are talking about two expressions, right? And they have a common factor of D. Now, if you look at the right-hand side, actually, what can be a common factor? Either 1 or 23, because 23 is a common factor here, which implies that then D must be 23 here, right? But here the question is find the value of D. So the value of D is 23. That's it. All right, now we have another theorem here for any integers A and D. And again, D is not equal to 0. And K, also K is some integer. There exists one and only one pair of integers, Q1 and R1, such that they satisfy this equation. A is equal to D times Q1 plus R1. And the K is less than or equal to R1 is less than absolute value of D plus K. Okay, that's just another way of actually describing this division algorithm. Well, what are we doing here? We know that actually already, if you are dividing A by D, if the remainder is R, right, that R is between 0 inclusive and less than D, not inclusive, right? On the right, it's not inclusive because if R is equal to D or absolute value of D, that means that still we can divide R by D. So it is less than this. That's why we stop division. Okay. So now that means I can just shift because here R is between these two numbers, means on the number line, right? Here we have 0 and here we have D, right? This is absolute value of D. And R is somewhere here, right? R is somewhere here. And now, but just adding K, what does it mean? What does it mean? We are just shifting this either to the right or to the left. And that actually just using this theorem, we can make some adjustment because sometimes you may divide, for example, a special negative number, right? Negative integer by another integer. So at the time, how can I keep this divisor smaller than half of the divisor? Okay, I mean this K. Anyway, for different values of K, different names are given here. So for K is equal to 0, that's our first case. Then R1 is called the smallest non-negative remainder. And if K is equal to 1, which means that actually K is now, if K is equal to 1, R1 is greater than or equal to 1, right? So that means that it is not 0, it is not negative, so it is the smallest positive remainder. And for K, where is equal to absolute value of D over 2, then R1 is called the smallest absolute remainder. Anyway, maybe we'll talk about this a bit later. Now let's just get one corollary, the result of this one. That let d is a positive integer, then the smallest non-negative remainder of dividing any integer by d must be one of 0, 1, 2, 3, 4, blah, blah, d minus 1. Okay. And it makes sense, right? Because if you divide any number, the remainder is, since it is less than d, right? If you're talking about positive integer, then what numbers are less than d between 0 and 1? These are 0, 1, 2, 3, 4, blah, 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 d minus 1. So the remainder must be one of these numbers. Actually, to prove this one, actually, we can just, how to say, group, for example, integers, right? If you can group any integer like in this form, for example, I can just group all integers like this: nk, nk plus 1, nk plus 2, nk plus 3, and here we have nk plus n minus 1, right? Now, if I just continue here, for example, let's say here we have nk, next one will be n, right? It is just n is a common factor. Here we have k plus 1. It just falls to the first category, right? The first group. So now I don't have to continue here. It's just repeating itself. So what does it mean? It means that if I given any a, let's say this one is the first integer, this is the second integer, I mean that integer. And well, uh, if you just pick any integer, right? If I just group in this way, that means that if you divide n, either the remainder is 0, or the remainder is 1, or remainder is 2, or remainder is 3, and until n minus 1, right? So it cannot be n, because if it is n, it's just again repeating the same pattern here. Like, for example, if I ask you about, let's say, any integer, how can I group this? For example, in terms of if n is equal to 3, for example, I can just group as 3k and 3k plus 1 and the 3k plus 2, right? If n is equal to 3, for example. And we don't have any other form, because other forms, 3k plus 3, again, that's just 3 times k. So how about 4? If n is equal to 4, I can just group it like this: 4k and 4k plus 1 and 4k plus 2 and 4k plus 3. Okay, which means that actually we are saying that if you divide any integer by 4, the remainders will be either 0 or 1 or 2 or 3. If you divide, for example, any integer by k, the remainder will be either 0, that's 5k, just like this, right? Or it will be 1, or it will be 2, or 3, or 4. Okay, good. Prove that for any 5 integers, there must be 3 of them such that their sum is a multiple of 3. Okay, so prove that for any 5 integers. That means that we are given 5 integers, and we are talking about 5 different integers, right? A and B and C and D. And we have to prove that actually there must be 3 of them such that their sum is a multiple of 3. Okay, if we just pick any 5 integers, right? So now the first, actually here, since we are talking about these integers, they must belong to one of these groups, right? Either, if you just pick any number, either it belongs to this group, or to this group, or to this group, right? So now, actually, if they belong to this group, we have no problem, right? Because it's already divisible by k, right? And how about if it belongs to this group, 3k plus 1, right? Or to this group, 3k plus 2, right? So now from here, if the 3 integers, they belong to this group, that means that I can just write it as 3 times k, or let's say, just if you pick any 3 integers, right? Let's say they belong to this group. That means that here, a is equal to 3 times k1 plus 1, and b is equal to 3 times k2 plus 1, and c is equal to 3 times k3 plus 1. Now, if you add this, here we have a plus b plus c, and 3 times k1 plus 3 times k2 plus 3 times k3. So that's equal to 3 times k1 plus k2 plus k3. And 1 plus 1 plus 1, that's equal to 3. And 3 is a common factor. I can just write this 3 times and inside the parenthesis k1 plus k2 plus k3 plus 1. And here is just the sum of four integers, right? It's also integer, which means that their sum is equal to, uh, their sum is divisible by 3. Okay. So prove that for any 5 integers, there must be 3 of them such that their sum is a multiple of 3. In a similar way, how about if they belong to the third group, 3k plus 2, right? And if you just add them again, so actually their sum will be divisible by 3. Given n is a positive integer, both n plus 4 and n plus 6 are prime. What is the remainder of dividing n by 3? Okay, since it is saying that it is n plus 4, n plus 6, and we need to find the remainder when we divide this n by 3. And since n plus 4 and n plus 6 are prime numbers, and again that number, right, this n, it may belong either to this group, that's 3 times k, or 3 times k plus 1, or 3 times k plus 10, right? Because here we can just group all the integers in this form. I mean, the integers those are divisible by 3, and the group, when we divide by 3, the remainder is 1. Another group, when we divide by 3, the remainder is 2. Right? If you just group in this way, at the time n should belong to one of these groups, right? Actually, suppose that n is a positive integer, and the n is, let's say, belongs to this group, right? In the first case, at the time, the first case, 3 times k, right, which is n, so that's equal to n. Suppose that n is equal to 3k, n is equal to 3k. Now from here, it says that n plus 6 is a prime number. So now n plus 6 is equal to, what is n? It is 3k plus 6, that's equal to 3 times k plus 2, which means that 3 times that number is divisible by 3, so that's not prime. So now it cannot be, right? It cannot belong to this group. And how about if it belongs to the second group, for example? How about if n is equal to, let's say, it is in this form. When you divide by 3, the remainder gives us the remainder 1. So at that time, if you just add, for example, again, n is equal to 4, right? N plus 4, that's equal to 3n plus 5. Okay, here we have, okay, 3, n plus 4, that's equal to n is, sorry, here n, for example, the first one, n plus 4, n is 3k plus 1 plus 4, it is 3k plus 5. So maybe this case is a possible case. And how about the third one, for example, if n is equal to 3k plus 2? At the time, n plus 4 again, right? What is n plus 4? That is 3k plus 4, right? And 3k plus 2, n is 3k plus 2, and plus 4. 2 plus 4 is 6. So here we have 3 times k plus 2. And also, it's not a possible case. The only possible case is n must be of the form, what is it? 3k plus 1. Okay. So now, since n is in the form 3k plus 1, the question is, what is the remainder of dividing n by 3? That means that since n is in the form 3 times k plus 1, if you divide n by 3, the remainder is, what is it? It is 1. So if you divide n by 3, the remainder should be 1. Right? Some examples, for example, let's say, what is it? If n is equal to, let's say, what is it? 5, for example, right? If n is equal to 5, this one is not 5, I think it is 7, for example. Let's say n is equal to 7, this one is 11, and also this one is, what is it? 13. 11 and 13, these are prime numbers, and n is equal to 7. If you divide 7 by 3, the remainder is 1. Or for example, if n is equal to, let's say 13. If n equals 13, for example, n plus 4, at that time it will be 17, n plus 6, it is 19. And what is n? N equals 13. And also if you divide 13 by 3, the remainder is 1. Just some examples. Now let's move. So a few questions from exercise 3. Okay. For the following sets of dividends and divisors, find the corresponding quotients and remainders. Okay, let's just write only two of them here. The questions are not so complicated. And for example, let's say dividend for 429, divisor 17, right? Let's do G and H. In G, it says that here 429, right? Divisor it is 17. So if you divide 7 by 17, what will be the remainder? So 429, if you divide 429 by 17, it is, what is it? Actually, the whole part will be 25 because it is 17 times 25, it is 400 something. So 17 times 25, that's equal to 425. So the remainder will be 4. So for the following sets of dividends and divisors, find the corresponding quotients and remainder. So here the quotient is 25 and the remainder is 4, right? And how about this 801 and dividing by 28, right? So here minus 801, let's say that's H, that is equal to 28 and our quotient is Q and the remainder is R, right? And again, 801, if you divide this by 28, it is 28 because 28 times 28, that's equal to 784. So this minus 801, I can write it as minus 28. Oops, what happened? 28 times 28. That's equal to 784. So here we have 17 plus 17. Okay. So that's equal to 17, 16. Okay, 17. That's correct. 17 is 6 plus 84. Or 4 plus 7 is 1. All right. So now from here, I can just write this. We are dividing by 28. So 28 times minus 28 minus 17, right? But here it is minus 17, but it should be positive, right? How can I make this positive? So since we are dividing by 28, I can just write it as 28 times minus 28. And here we have, what is it? Minus 28, right? Plus, and the minus 28 plus what number is minus 17? That's equal to 9, right? Because it's not 9. See, it is 11. What happened? Okay. All right, minus 28 plus 11. So now 28 is a common factor, right? If you just take this out, now 28 minus 28 minus 29. So here we have minus 29. Here we have times and plus 11. So here, then the quotient will be, what is that? Let me just write here. Quotient is minus 29 and the remainder is 11 because remainder should be positive. Question 2, the remainders of dividing is 300, 262, and 205 by D are equal. Find the values of D, right? So, okay, we just did similar question here. If you divide 300, 262, and 205 by D, they are equal. That means that if you divide like 300 and divide by D, the quotient, let's say Q1, the remainder is R. And again, if you divide 262 divided by D, and the quotient is, let's say, Q2, and the remainder is again R. And here we have 205. If you divide this by D, the quotient is Q3, and the remainders are. Because if you divide all of these numbers by D, the remainders are the same, equal. So now here we need to find the value of D. Again, we'll just use that theorem, right? If M and N are divisible by D, and also their difference is divisible by D. Which means that now if you just apply that theorem to this question, 300 minus 262, that's equal to 38. On the right hand side, R minus R, that's equal to 0. D is a common factor. Here we have Q1 minus Q2. And the second one, 262 minus 205, that's equal to 57. And here we have D, R minus R, that's equal to 0, Q2 minus Q3. So here we have Q2 minus Q3. Now 38, right? 57. What actually is the common factor of these two numbers? 38 is just 2 times 19, and 57 is 3 times 19, which implies that here D must be 19. So the value of D is 19. Another question, the sum of A, B, and C is 100. The quotient and remainder of dividing A by B and dividing B by C are equal to 5 and 1 respectively. Find the value of the numbers. So here we are given three numbers, which means that A plus B plus C, their sum is equal to 100, right? And it says that if you divide A by B, the quotient is 5, the remainder is 1. That means that A is equal to 5 times B, and the remainder is 1. And also if you divide B by C, right, the quotient is 5 and the remainder is 1, because it says quotient and remainder. It is 5 and 1 respectively. So here if you divide B by C, again the quotient is 5, that is 5 times C, the remainder is 1. Right, and now here we have three equations, right? Three equations, three variables. That means that we can solve them. So the only way is we are going to use here is elimination and substitution method. Now actually I'll just reduce the number of variables and get one equation in one variable. How is that possible? In the first one, instead of A, I can write B, right? Because A is equal to 5 times B plus 1. And instead of B, I can write C. Okay, from the first equation, I think I should express everything in terms of C. So A is equal to 5 times B plus 1 equals, what is B? B is 5C plus 1. So that's 5 times B is 5C plus 1, which is equal to 25C. 5 times 1 is 5 plus 1, that's equal to 6. And how about B? B equals 5C plus 1, and C is equal to C. Now, if you substitute into the first equation, instead of A, we can write 25C plus 6. Instead of B, we can write 5C plus 1. Instead of C, it's just C. On the right-hand side, we have 100. So it's just simple linear equation, 25C plus 5C plus C, that's equal to 31C, equals 100. 6 plus 1 is 7. Take to the right-hand side, 100 minus 7, that's equal to 93. Now from here, what is C? C is equal to 3. If C is equal to 3, then substitute into the first equation, right? We can get B. What is B? B is 5 times C. It is 3 plus 1. That's equal to 16. And if C is equals 3 and B equals 16, what is A? A equals 100 minus A minus B, that is minus 16 minus 3. It is 19, that's equal to 81. So A equals 81. So let me just write here, dot, dot. A equals 81, B equals 16, and C equals 13. All right. Let's move to the next question. In this question, if 1 is added to 1, then it will be divisible by 6. Okay. If 3 is added to n, then it will be divisible by 8. If 5 is added to n, then it will be divisible by 10. the sum of the quotients of dividing n by 6, 8, and 10 is equal to 235. Find the value of n. Okay, so now the first part of the question is saying that if you just add 1 to n, that is n plus 1, that is divisible by 6. So which means that I can write it as 6 times some integer. Let's say it is capital A. Okay, A is integer here. And if 3 is added to n, that is n plus 3, it is divisible by 8. So that is 8 times some integer b. And if 5 is added to n, that is n plus 5, right? And it will be divisible by 10. So that is 10 times c. The question is saying that the sum of the quotients of dividing n by 6, 8, and 10 is equal to 235. So that means that first I should express this in this form, right? That means that we are talking about like this. And if I divide this n by 6, 8, and 10, that means that simply if I just divide by d and q, and here we have the remainder. So when d is equal to, what is it? 6, 8, and 10, right? And here we have the quotients are q1, q2, q3, and the sum is equal to 235. Now from here, what can I do here? First, as see here, if you just add 5, all of these numbers are divisible by 6, right? So now if you add 5, it will be minus. So what I have to do here is, let me just write first like this. So n is equal to 6a, take minus 1 to the right-hand side, minus 1, right? So this 1, 6 times a, I can just write it as 6a minus 1 plus 6 minus 1. Because 6 times minus 1 is minus 6 plus 6 just equal to 0. And now here we have minus 1. Now I can just write it as 6 times a minus 1 plus 5. Okay. In similar way, the second one is n equals 8a minus 3, which is equal to 8 times, and it's not a, it's b. b. So that is b minus 1, and 8 minus 3, that's equal to 5. And again, n equals 10c minus 5, and that's equal to 10 times c minus 1. And here we have 10 minus 5, that's equal to 5. Right? Now, as see here, if I just divide n by 6, right, remainders 5, divide n by 6. Okay, remainders we're not interested. Here, when you divide n by 6, 8, and 10, the quotients are a minus 1, b minus 1, and c minus 1. It says that the sum of the quotients of dividing n by 6, 8, and 10 is equal to 235. So that means that here we have the quotients are, it is a minus 1, right, plus b minus 1 plus c minus 1. That's equal to 235, right? So now from here, can we find what is a minus 1? A minus 1 is just, what is it? Maybe I can write first. Okay. All right. All right. From here, a plus b plus c is equal to 235. Take minus 1, minus 1, minus 1, minus 3. Take to the right-hand side is 238, right? Now from this first equation, right? From the first equation, what is a? A is n plus 1 over 6. And from the second one, no, actually, I think I should use the first one. It's much better. Okay. Here, from here, these expressions, right? And we can just take 5 to the left-hand side, 5 to the left-hand side, 5 to the left-hand side. At that time, a minus 1 will be equal to n minus 5 over the first one is 6. And b minus 1 is equal to n minus 5 over 8. The third one, right, take 5 to the left-hand side and divide by 10. C minus 1 is equal to, what is it? N minus 5 over 10. Because these are the quotients, right? When we just divide n by 6, right? What is the quotient? If you divide n by 6, the quotient is a minus 1. If you divide n by 8, the quotient is b minus 1. If you divide it by 10, the quotient is c minus 1. And here the question says that sum of the quotients of dividing n by 6, 8, and 10, right? So the sum of these numbers, I think I don't need this line. So the sum of these numbers, that is n minus 5 over 6 plus n minus 5 over 8 plus n minus 5 over 10. That is equal to 235, right? So now n minus 5 over 2, it's a common factor, or, okay, n minus 5 over 2 is a common factor. Here we have 1 over 3 plus 1 over 4 plus 1 over 5. That's equal to 235, right? Now from here, what is 1 plus 1 plus 1 over 3 plus 1 over 4 plus 1 over 5? So we can just write this n minus 5 over 2 times the common denominator is 60. So the first one is multiplied by 20. Here we have 20. The second one is 15, and third one is 12, right? It is 35, 47. That's equal to 235. Okay, I need more space. So now from here, what is n minus 5? N minus 5 is equal to 235 times 2 times 60. It is 120 over, here we have 47, which is equal to 235 is divided by 47. That's equal to 5. 5 times 120. That's equal to 600. Now from here, we need to find n. What is n? N equals 600 plus 5. So that's equal to 605. All right. Next question. Michael buys 5 rubbers, 7 rulers, 8 pencils, and 12 ball pens for $74.7 or $74.70. If the prices of one rubber and one ruler are $2.3 and $1.4 respectively, had the cashier made a mistake? So now hereby we just need to find is the mistake or not. So here 5 rubbers, right? And 5 times 1 rubber is $2.3. $2.3 plus, and how many rulers? 7 rulers. 1 ruler is $1.4. So it is 7 times $1.4. And plus 8 pencil. Let's say it is 8 pencil. The price of 1 pencil is P dollars. And 12 ball pens. Let's say it is 12 times ball pens. Let me just write here B. That's equal to 74.70. Now from here, I can just write this 8p plus, and the variables keep it on the left hand side. So here we have 8 times p plus 12 times b is equal to 74.7 minus 5 times 2.3, that's equal to 11.5, minus 7 times 1.4, it is 7, 2.8, that's 9.8. So now here 74.7 minus 11.5 minus 9.8, that's equal to 53.4. So here we have 8p plus 12.6 and 12b is equal to 53.4, right? So now both numbers are divisible by 4. I can just simplify this further because 8 and 12, they have a common factor of 4. So it is 2p divided by 4. And here we have 3b is equal to 53.4 over 4. And which is equal to 13.35, right? And just buying, I mean, the prices of 2 pencils and 3 ball pens is equal to 13.35. So there's nothing wrong here. So the cashier didn't make a mistake. And had the cashier made a mistake, the answer is No. Right, because we have a lot of possibilities that the price of pen and ball pen, right, multiplied by 2 and multiplied 3, that's equal to 13.35. Okay. Another question, question 6. If both the remainders of dividing 4-digit number n by 7 and 9 are equal to 2, how many possible values does n have? Right. So we are talking about 4-digit number. Okay, 4-digit number is, what is it? If both the remainders are dividing 4-digit number n by 7 and 9, so that means that n is 4-digit number, means it is greater than or equal to 1000 and less than or equal to 9999. So n is between 1000 and 9999 inclusive, right? And it says that if both the remainders of dividing 4-digit number n by 7 and 9 are equal to 2. That means that if you divide this n by 7, and let's say here quotient is q1, the remainder is 2. And also if you divide this 7 by 9, and the remainder is again 2. Now from here, as you see, if you just subtract, right, what we have here, subtract the first equation, n minus n, it is 0. 2 minus 2, it is 0. And here we have 7 times q1 minus 9 times q2, which implies that 7 times q1 equals 9 times q2. And we know that 7 and 9, these two numbers are relatively prime numbers, which means that actually this q1 must be divisible by 9 and q2 must be divisible by 7. Otherwise, these two expressions, they cannot be equal to each other because they don't have any common factor, which means that actually here, that means that this n should be divisible by, what is it, 7 times 9, that is 63k. So it must be this form. Okay, so that is divisible by 23. As you see here, sorry, it's not like this, not yet, which means that here, this q1, right, q1 is also divisible by 9 and q2 is divisible by 7. That means that I can write this one in this form. N is equal to 63 times sum a, okay, plus 2. And this n is equal to 63 times sum b plus 2, right? Now from here, what is 2? I mean, what is n? So that means that here, n minus 2, right, is divisible by 63 and sum k, right? So if n minus 2, all right, I think not, because since it is 63, right, because it's the same number. So that means that I need to write like this. Okay, since from here we are drawing this conclusion. Okay. All right, since q1 is divisible by 9 and q2 is divisible by 7, that means that here this n should be divisible by 63. And here we have sum k, and so here we have 2. Okay. So now from here, we know that n is between 1000 and 999, right? Now, if you substitute there, just we need to find the possible values of k. So here we have 1000 less than or equal to 63k plus 2 less than or equal to 9999. So now if you subtract 2 from all of these numbers and divide by 63, what we have here? Here we have 998 over 63 less than or equal to k less than or equal to 9997 over 63. And if you divide 998 by 63, it's about 15 point something, okay? So that means that here we have it is 15 point something, or let me just write here 8, for example. It's about 84 something, greater than or equal to k, less than or equal to 9997 is divided by 63. It is 158.6. So it's 180.6. Okay, which means that between this, what are the possible values of k then? Possible values of k are starting from 16 and 17 dot dot and 158, right? So that was the question. How many possible values does n have? Now from here, number to find the number, 158 minus 16 over increasing by 1 plus 1, that's equal to 142 plus 1, that's equal to 143. The answer is it has 143 possible values if it is a 4-digit number. And when we divide by 7, the remainder is 2. When we divide by 9, the remainder is 2. So we have such 143 different 40-digit numbers. We satisfy all of these conditions. Another question, if the remainders of dividing 3-digit number n by 6 and 11 are equal to 3 and 8 respectively, find the sum of the possible values of n. It's also a similar question, but here we need to find its sum. And here we are talking about the 3-digit number. 3-digit number is, so here n is, what is 3-digit number is greater than or equal to 100, less than or equal to 999, right? So we are talking about 3-digit number. So it says that if the remainders of divided 3-digit number n by 6 and 11 are equal to 3 and 8. So that means that n, if you divide this by 6, let's say here we have a, the remainder is 3. And if you divide this n by 11, right, the quotient is b, the remainder is 8. And find the sum of the possible values of n. So again here, as you see, if I just add 3 here, for example, what do we have here? N plus 3. On the right-hand side, we have 6a plus 3 plus 3. That is 6 times a plus 1. The second one, also, if we just add 3, the number is divisible by 11. So here we have m plus 3 is equal to 11 times b plus 1, which means that here 11 times 6, right? And again, 11 and 6, they are relatively prime numbers. So that means that an n plus 3 should be divisible by 6 times 11, which is 63. 6 times k. So now from here, what is n then? N is 66k minus 3. N equals 66k minus 3, right? So now first we need to find the possible values of k. Now if you just solve it for 100, so here we have 100 less than or equal to n. N is 66k minus 3 less than or equal to 999, right? So first I should add 3 and divide by 66. So here we have 103 is divided by 66 less than or equal to, here we have k less than or equal to, if you add 3 to this number, we have 1002 and over 66. And 103 over 66, we know that it's greater than 1, less than 2. It is 1 point something. So let me just write 103 is divided by 66. That's equal to 1.56. That's equal to 1.56. Just let me just write 1.6. Greater than or equal to k, less than or equal to 1002 is divided by 66. That's equal to 15 point something. 15.1. Or let's say 2. So actually, since k is here natural number, what are the possible values of k then? That is, k is starting from 2 until 15, right? So that are the possible values of k. So in the question, we need to find the sum of these numbers. What is n actually? N is 66 minus k, right? So now, if you just write this sum, like for example, how many numbers here we have? We have 15 minus 2 plus 1. Here we have 14, right? So let me just write here. So the sum of these numbers are, if k equals 1, here we have 66 times 1, not 1. It is 2 plus 3. Okay. It's not plus 3, minus 3. Okay. 66 times 2 minus 3 plus 66 times 3 minus 3 plus dot dot, and 66, the last one is 15 minus 3. Okay. So now the first part, right, the 66 is a common factor. Just take this out, and inside the parentheses here we have 2 plus 3 plus until 15 minus, and here we have 3's, how many? 14. So here we have 14 3's. And the first part is 66 times just the sum of the natural numbers, but excluding 1. So that's just equal to 15 times 16 over 2 and minus 1. And here we have 3 times 14 is equal to 42. So now if you simplify this, 66 times 16 over 8, I mean 16 over, that's 8, 8 times 15, that's equal to 120 minus 1, 119 minus 42, which is equal to 66 times 119, and we should subtract 42 from this result. The answer is 7,812. So the sum of these numbers is 7812. All right. If the remainder of dividing by d is 14, find the number of possible values of d. So that means here 2009, right? And if we divide by d, right, if the remainder of dividing 2009 by d is 4. So the quotient is q, the remainder is 14, right? So that means that what are the possible values of d? So now here, first, if you just take 14 to the left-hand side, then we have here d times q is equal to 2009 minus 14, which is equal to 1995. So that means that this d times q is equal to, what is 1995? 1995 is just, it's divisible by 5. 1 plus 9 plus 9 plus 5, it is divisible by 3. It is divisible by also 7. Okay, if you just divide by 3, for example, it is 3, and also I can divide by 5, and if you divide by, also continue dividing, also is divided by 7, and it is 9. Actually, 1995, it can be written as 3 times 5 times 7 times 19. That's the prime factorization of this 1995, right? Now from here, we are talking about this d. We know that it's just integer. Also, you need to include negative integers here, right? So that means that d can be plus minus 3, or plus minus 5, or plus minus 7, or plus minus 19, right? But here it's saying that the remainder is, what is it, 14, right? So when we just divide by this, the remainder is 14, which means that actually this remainder 14, it should be less than positive value of d, right? So what are, which actual numbers positive values less than d? That is plus minus 3, right? Plus minus 5 and plus minus 7. Right? Because this divisor, right, the remainder cannot be greater than d. So it should be less than d. So what numbers here, they are greater than d? So that means that, let me just write here some possible values of d. So possible values of d, it can be plus minus 19, right? Because 19, it is greater than 14. Or simply, I should just write like this. Absolute value of d should be greater than 14. And it cannot be plus minus 3, it cannot be plus minus 5, but the combination of these numbers, right? 3 times 5 is greater than 14, so it is plus minus 15. And 3 times 7, it is plus minus 21, right? And 3 times 19, that is plus minus 57. Okay, with 3 we are done. And 5 times 7, it is plus minus 35. And 5 times 19, plus minus 95. And also with 5 we are done. And 7 times 19, it is 70, 63, 133, right? Plus minus 133. And after that, odd number, okay. The product of the whole numbers, that is plus minus 2009 and plus minus 2009. How many here? We have 1, 2, 3, 4, 5, 6, 7, 8. So altogether 18 possible answers. Okay. So we have some more questions, 9 and 10, 2 questions left. So distribute the homework. Thank you very much.